Here we are. So I suppose Dean already welcome you all to this webinar about lifecycle overview. So this is one of the many topics that we cover during this kind of events. And considering the good feedback that we received so far from the participant, we continue sharing our knowledge regarding intrinsic safety and functional safety. Brief introduction about myself. I'm Gabriele Caglio. I'm a technical support specialist here at GMI, and we have Tino van de Capelle, which is, of course, the expert and today's main speaker. A little introduction about the company, about GMI, for whom doesn't know us. GMI is an Italian company providing field interfaces related to intrinsic safety and functional safety. This means that it's possible to find GMI devices in many industrial packages, such as DSC, ESD, fire and gas, and so on. As you can see on the screen, we're talking about oil and gas, petrochemical, pharmaceutical, mining, but also food and beverage, and many other industries. We have about 40 years of experience in the field, and the headquarters, as I said, is in Italy, where we have our main facility and where we design, produce, and test all our products. This slide is about where GMI is present all over the world. So we have 9 offices and resellers. So we are pretty much everywhere and close to our customers. As I mentioned before, we are a safety company, and we aim to provide safety and reduce the risk of a hazardous event to safeguard people, assets, infrastructures, production processes, and the environment too. For this reason, the quality aspect of our product cannot be overlooked. So we design our product, we manufacture and test them 100% internally, meaning that we do not outsource any of these tasks. So that's why we are confident about the quality of our product. Few more slides before to get into the real part of the webinar. This is about the certificates we have, or at least the certification bodies we are dealing with. This guarantees the quality of our devices, but also guarantees that GMI products comply with the market requirements according to different local regulation. Okay, this is our portfolio, so a quick overview about it. As I mentioned, we have intrinsically safe barriers, we have safety relays, SEAL certified with and without light monitoring to energize to safe and de-energize to safe application. We have isolators, AX power supply system up to SEAL 3, temperature and digital multiplexer for zone 1 installation. We also have customized termination board for an easy connection to the main PLC and DCS systems. We have ARC multiplexer, surge arresters, and then we also provide consultancy, and we share our experience through courses related to functional safety and intrinsic safety. The last slide. Okay, so this is a list of some, sorry, one too much.
I can see there is a small delay between
yes,
and
let's say small, but I clicked.
If you want,
yeah, if you can go back just one, but it was just the last slide.
Here we go. Okay.
There are, I can't see it, but it's okay. It's an overview of our customer, which stretches from system vendors, EPC, OEM, and end user. I've heard Tino mentioning about the webinar. Yeah, here we are, some of our customers and the companies we are dealing with on a daily basis. So the last thing about the webinar, probably Tino already told you that, but this webinar is recorded, and in a few days you will find it available on our YouTube channel. You will get a link to download a PDF copy of this presentation in a couple of days from now, and also a certificate if you attend at least 75% of the webinar. And if you have any question during this presentation, please write it down in the Q&A session, and we'll answer it from there. Okay. They're all yours, Tino, please.
Thank you, Gabriele. Thank you. Okay, so now everything should work without a time delay because there was some trouble I saw with controlling the screen, but hopefully they don't disturb too much. So topic for today is actually a very generic topic. It's also a very neutral topic in terms of there's no specific activities we are discussing other than what is the real reason why we have a systematic approach on carrying out, can be in operations, can be in maintenance. So all the activities are described in the IEC 61511 life cycle. And the IEC 61511 life cycle overview, that's the topic that we selected here for today. Taking you back into a little bit of history, where does the functional safety standards originally coming from, or how did it start? If you go back to 1996, ISA 8401, and the 8401 was the first time there was a document in the market to describe a activity approach on how to carry out your work in building a safety system. So that was the first safety lifecycle quantitative approach at the time in 1996. And basically the idea of the 1996 standard or the life cycle came initially from the IEC 61508, because you should not forget the 61508 standard initially was drafted, let's say, mid of the 90s. And already in the committee of the IEC 61508 were also people that were of the committee member of the 8401. So long story short, the US or the ISA committee brought out earlier the life cycle than the IEC committee of the 61508, as there was some delay. Initially, the first edition came out in 1997. In 1997 was the first time in our, let's say, industry that we heard about the new definition called safety integrity level, or the famous SIL level. It's very rare today to meet an engineer in business that would not know what SIL really means. So SIL is well established by now. They think they know what it means. That is always what I'm joking in my is, do they really know what you can achieve or what you can try to express, which is a safety integrity level? Anyhow, in the 61508 edition 1, 1997, we were introduced to 4 levels: SIL 1, SIL 2, SIL 3, and SIL 4. And then as there was a progress from 1997 to the early stages of the year 2000, 2001, the end users in the process industry were trying to apply the 61508. But they very quickly found out that if they would try to build it as the requirement for the 61508, their configuration or the architecture would be quite expensive. So in other words, there was a need for a dedicated application-specific standard. And that's a topic here for today. We will speak about the IEC 61511, and there were some pre-registered questions coming in before the webinar that I already answered. So after this slides pack, I will give you also some answers to the questions that I picked out of the list. But the 61511 was only dedicated to be used for the process industry. And back in the US, as you have seen the ISA 84, we crossed it out there. The 1996 has been replaced with a new version, which was called the ISA 8401 with the asterisk. Asterisk means the US adopted it with one additional clause to the standard of this IEC 61511, and we call that the grandfather clause. And the grandfather clause, basically, in a nutshell, was saying that we do a gap analysis to an old existing installation. We see how far the gap is from the new requirement from the IEC 61511, and that gap needs to be closed, enabled to achieve your safety. I can see there is a question coming in, but I will leave this for the moment. Okay. I will first continue. Oops. So then we are moving in the year 2010. And the year 2010 was the new edition 2, a revised edition 2 of the IEC 61508. And the IEC 61508 is a neutral functional safety standard. for everything to do with electricity, electronic components, or programmable electronic safety related system. That is what the standard title is saying. It's functional safety for EEPES. And with the new edition 2, they introduced a complete different concept, which is now being differentiated between road 1H and road 2H. And road 1H, I call that the theory approach from a manufacturer that is starting a new development of a new component. The road 2H means you have already some install-based installation, you're collecting some file data, that is called road 2H, which we also called proven use. Another thing they introduced in the year 2010 was the systematic capability. So it is no longer enough for a manufacturer to claim SIL 1, 2, or 3 on a compliance device. We also need to find out what is the systematic capability per subsystem or per device. We are moving in the year 2016, 2017. There are 2 dates there for the simple reason. When the edition 2 of the IEC 61511 was being revised in the year 2016, they realized that they actually released an older draft of the standard. That means that they made a mistake, and that is what was called the corrigendum. There was a corrigendum coming out in September 2016, plus there was an amendment coming out in August 2017. So the final release today that engineers can refer to needs to check for the year 2017, what we also call here between brackets, the CSV stands for the consolidated version. Part 2 and part 3 are the informative part. So we always distinguish, we always make a difference. What is now normative in the standard? And if you are required in engineering or in design or in operation or in maintenance to comply to the IEC 61511, well, then the minimum you need to prove evidence is that you comply to part 1, which is a normative section of the standard. Part 2 and part 3 are the informative section of the standard, and I think I have also a slide coming up to show you that later. What was totally new in 2016, so it's 8 years new today, it's called security risk assessment shall be carried out as part of your process hazard and risk assessment on your installation. And then at last, we are moving in the year 2018. The US, the old ISA 84 committee, waited to adopt the edition 2 of the 61511 until the corrigendum was out, until the amendment was out, and then finally in September 2018, the ISA 84 has changed the name and is now called the ISA 61511, which is a one-to-one copy to the current edition 2 of the IEC 61511. That's a slide I was just remembering instead of explaining. I made a slide for it. So you see here 3 different parts. The blue text is English, the gray text is in French. In the old days, edition 1 was always double pages, was like English and French on both sides. Now, in the meantime, you can buy or you can purchase only English or only French, depends on the language that you prefer to use. And you see here in part number 1, which is here called IEC 61511-1, 2016, that's the initial edition 2 that came out. Plus they made an amendment number 1 here, 2017, that is the CSV or the consolidated version. You are looking for about 84 pages of text. And the 84 pages of text will explain you, of course, the framework of the standard. What is the framework that you have to look at? And one of the key issues of the framework is, of course, the life cycle. And the life cycle is a topic that we will explain here today. In the life cycle, activities will be described on how to do your project planning, how to manage your life cycle activities, what technical requirements you need to comply to enable to achieve a certain SIL level, what documentation requirements, and what is also changed by the edition 2 is the competency assessment. There is a periodic assessment required to prove that everyone in the standard activities or lifecycle activities is competent for what they are accountable or responsible for. We have the first poll question coming up, Gabriele. I don't know if you have the polls also ready with you.
No, I don't see the panel in my screen here with the launching the poll. Today,
All
it's
right. Well, let's see if I can see the poll. I see them here. Okay, let me try to launch them over here. Can you see the poll now, Gabriele?
yes.
Okay, so the question is, let me first move the poll a bit on the side. I am just interested to get some feedback from the audience here today. Who of you have access to the current edition 2 of the IEC 65011? Or if some people from the US, although it's early morning here in Europe, so I doubt that someone in the US would stay up at midnight to listen to a webinar, but maybe you never know. So if you have someone from the US in the panel, then you will refer to the ISA 65011 2018 standard. And you have a choice between I have access to one of them, but have not read or used them, which is typically the excuse that engineers would tell us if we do some inspection or assessment. I have access to one of them and I'm using it. That's answer B. C, I have no access to none of them. D, I'm using the old edition number 1. And E, none of the above. All right, so at least we get some feedback. Let me see. I need some more clicks. So don't be afraid. There is no prize to win or to lose. There is no image to win or to lose also. It's just for me evidence that I keep talking. Otherwise, I stop talking if no one is willing to make a simple click on the button. All right, so I think I can end the poll because we have quite a good number of people clicking on it now. All right, let me share the results. So you should see the results now. That majority, 33% said I have access to one of them, but I have not read or used it. Well, that's it's good that you have access to them, but of course, depending on what is your role in your activities or in your responsibilities in your business. The second group, 24% is saying I have access to one of them and I'm using it. Well, that is what we really were hoping for, that there would be more people than that. There are 29% saying we have no access to none of them. So that's, if you are in safety business, that is certainly not good at all. For the 5% who said we are using the old edition, that's also not good because the old edition is obsolete. That means since the year 2016, we are no longer using the old edition. There is nothing in the industry, in engineering, or in inspection, or in insurance that will approve that you are using an old edition for a current installation that you are building. Of course, if your plant is 60 years old, don't worry about it. If you are in a new project for the last 5 or 6 years, worry about it. None of the above, that's 10%. Well, that's the engineers who have no access. That's, of course, also not to create a good engineering practice in the industry. Let's stop sharing this and let me keep on going. Right. What is the life cycle based on? There are 2 different items in here. As already mentioned to you, we have a normative section that is all the blue color here on this slide. And you see on the first column here, that's all the technical requirements. And you will see everything which is blue is coming out of part 1, which I already explained you is the normative section of the standard. You see also the supporting part. So there is, of course, a lot of supporting part text in part 1 in the normative section. And part 2 and part 3 are the informative section. Informative means it is the subjectivity or it is the interpretation of the engineer. In part number 2 and part 3 will be additional information, hopefully, that will help the engineer to understand what part 1 normative section is requiring. The standard is performance-based. That means you still have to do something. It's not prescriptive. They will give you some ingredients. Example, if you have to cook dinner tonight and you have to cook a tomato soup, they will give you all the ingredients for your tomato soup. They will explain you what the soup is containing, but they will not cook it for you. That means you still have to cook it yourself. That's the same with the activities life cycle in the 65011. It will be described in a certain sense, but you still have to carry out according to the recipe of the life cycle. The fundamental concepts remain the same in addition to. We still remain the same life cycle. They only change one small word. There is a word here in the middle. It's small text here. I don't have my glasses on, but it should say here design phase for application programming, which I think it does. That's clause number 12. And clause number 12, that is chapter number 1, used to be called software programming. We call this now application programming. And the main thing they have changed in the application programming, we call that the 4I principle. That means the initial author who wrote the application program in the safety PLC cannot verify the, let's say, functionality of his own program. The verification needs to be done by an independent from the author, competent person to prove that the functionality of the application program is good. That is the thing that is mainly changed in the edition 2 on the application programming. The factory acceptance test, or the FAT, became normative, although it was in part 1 in edition 1. They call that chapter 13 factory acceptance test, and in edition 1 they say between brackets informative. So it was like mind-blowing that you would build a system, not testing it, shipping it on site, and say we will find out if it works or not. Of course, that doesn't make sense. So by edition 2 they made it clearly, logically, they make it normative. And all the references in the standard, the Lifecycle, are based on the IEC 61508, which is the edition number 2. Two main fundamental concepts remain, as I just explained. The life cycle. What is the life cycle? To explain this simple to people who are not been involved yet or have never seen a life cycle. The life cycle is nothing more than a systematic approach for the engineers to do something systematic. So it's a working method. It's a scheme. It's a working method scheme that step per step, it will explain you on how to approach and how to achieve and how to prove it. That is the life cycle. So in a nutshell, it's good ideas that the committee members came up in text, hopefully to avoid and hopefully to reduce design mistakes or human mistakes in carrying out those activities. They call this a good engineering practice. So the standard IEC 611 is based on a good engineering practice. It's also still a performance-based design. That means that we will need to prove by an estimate what is the availability, what is the likelihood that my system will be able to carry out the safety function when I need it. That is what we will do when we are estimating our availability in terms of the PFD calculations. And the PFD calculation stands for the probability to fail dangerous upon demand. And that is what we are using to express the performance band of our SIL. So a SIL 1 performance band is 10 times less performing than a SIL 2. A SIL 1 performance band can perform very, very minimum SIL 1 or very, very maximum SIL 1. So you always have a bandwidth. Start from a risk reduction factor 10 to maximum 100, that's a SIL 1. From 100 to 1,000 is a SIL 2. From 1,000 to 10,000 is a SIL 3. And here we have the life cycle picture. So just quickly check because I haven't given this webinar for a while. All right. So the life cycle, I will start here by pointing out that number 1. You see on the left corner, number 1 on the first block, on the first activity, which is always a start on any project. We are trying to identify the hazards in our production. We then, once we know what hazards we are dealing with, we will then start to do the hazard analysis. With the hazard analysis, we need to answer 2 questions: how likely the hazard will happen and how bad or how much consequence we will have. Once we know the frequency or the likelihood, and once we know the consequence or the severity of the consequence, that is where we have to look into our tolerable risk criteria from the corporate level, potentially as an example. The corporate level will tell you what is accepted by us, what is not. And based on what is not accepted, we will have to reduce the risk. So the risk assessment is comparing to the tolerable risk criteria and will define how much performance do I have to reduce my risk. The second activity phase We call that the layer of protection, or the engineers typically will say LOPA. And with LOPA stands for layer of protection analysis. You will look on the different layers that are on top of each other. Each specific layer needs to be independent, separate from each other. There is, in addition to some theory, that you can take some credit for a normal BPCS or a DCS layer with the maximum risk reduction factor equal to 10. Well, that is the risk reduction factor that we will allocate to one specific layer. If that layer or the other layers are not giving you sufficient risk reduction, that is where you will have to design or define first an additional layer, which is called the safety instrumented system. And before you're going to design it, it needs to be specified. So one of the key documents on any project is the safety requirement specification. In other words, when there is a need for an additional risk reduction, we will actually have to define that in a document which is called the SRS, or the safety requirement specification. From the safety requirement specification, we go into phase number 4. And in phase number 4, we have a design and engineering of the safety instrumented system. And you can see here we have reference to clauses 11, 12, and 13. All the clauses which were shown already in the boxes are nothing more than the reference of the chapter number of part number 1. Remember, part number 1 was the normative section. That means if you open part 1 of the IEC SIG 1511 and you would go and read chapter 11, chapter 11 will have as a title Design and Engineering of Your Safety Instrumented System. Chapter 12 will say your application programming, and chapter 13 will tell you the factory acceptance test. If I go above to my phase number 3, my safety requirement specification, every single safety loop or every single safety instrumented function shall describe and shall include 29 specific items that your safety function needs to be described in. That safety requirement specification or that loop is also being defined in the book from GMI as an example in chapter number 8. And that is described in the IEC 611 here in clause number 10, which is chapter number 10 of part 1 of the 61511. Other means of risk reductions, that means that when you are doing the LOPA exercise, when you are allocating safety functions to existing layers, the first thing the IEC 61511 will tell the engineers, please, do not directly or immediately decide to build a SIL loop or a SIV loop. Do not immediately build an instrumented system. First, look for other alternatives which are different than a safety instrumented system. So design and development of other means of risk reduction is the preference of the IEC 61511 standard. If you're running out of options, then you are coming into your safety requirement specification. But the first thing before we start to build a loop or the system, we first seek or look for other alternatives. Then we combine the safety instrumented system and also here my design and other developments of means of risk reduction together. That is what we will do here in the installation, commissioning, and validation, which is still called phase number 5. All the phase numbers remain the same from edition 1 to edition 2. And that is referring here to clause number 14 and clause number 15. And once you have done your site acceptance test, which is known as the validation, that is typically known also in the industry that we talk about the PSSRs, which is the pre-safety startup review. And the PSSR is typically what we do here if you refer here to the stage number 3. You may have noticed I skipped stage 1, I skipped stage 2. Well, all the stages 1, 2, 3, 4, 5 is another webinar. Those are the functional safety assessments. That is the evidence that we need to see in your projects, that you comply to the standards in terms of an inspection, in terms of an assessment. And the assessment needs to be done by at least one member needs to be the senior competent person, not involved in design for stage 1, 2, 3, not involved in the operator and maintenance for stage 4 and 5. And then finally, we give it over to the operator and maintenance, to the end users. That is phase number 6. In phase number 6, which is described in chapter number 16, what is the biggest change by addition to? There is now a periodic requirement for doing a assessment, which is called here stage number 4. And stage number 4 is periodic. We want to make an inspection assessment by an expert judgment. Again, senior expert, independent from the same operations, from the same maintenance, from the same sys. So there are two different groups, independent from design for stage 1, 2, 3, independent from ops and maintenance for stage 4 and 5. Almost at the end of the life cycle, any existing installation at a certain point of time, you will try to carry out, or there may be a need to carry out a modification. And before you start to do a modification, we still have the management of change, or the MOCs, as some of you may recall. With an MOC, you have the request of the modification, you have the impact analysis, means someone has brainstormed about the impact potentially. We need to have the authorization from the whoever is authorized to authorize the let's say the modification to be carried out. And then before we start the modification, what is new by addition to, we need to have again an independent senior expert judgment by an assessment called stage 5, not involved in the same operation, the same manage of the same sys. We carry out the modification, and before we're going to start up again, we need to do a second stage 5 assessment on the result of the modification. All of that is explained in different webinars from GMI. So if you go to the YouTube channel, you will find many of those topics already covered. On the left-hand side, we have a generic block here, or a generic phase activity, which is called the FSM, or the functional safety management, which is described in clause number 5 or chapter number 5 of the edition 2 for part number 1, 6, 15, 11. We call that here phase number 10. Phase number 11 is everything to do with the planning of the life cycle activity and with the documentation, etc. And the last one here on the right-hand side, this is here my phase number 9. And in phase number 9, that is known as the verification. The verification is a very specific chapter described in the IEC 6, 15, 11. In other words, we need to prove evidence by a investigation verification resulting into a verification report. And that verification report is nothing else than proof to us, if I would be the inspector, prove to me that you carry out your activities as per requirements. That's described in chapter 7. And the 4I principle, which already mentioned in the introduction, that's 12.5. That means that's specific for the application programming of a safety PLC logic. There needs to be an independent 4I principle. That means an independent person other than the author needs to prove with a verification. But the standard is quite clever written in the sense of, it's not only good to say we have a second name, person A program, person B has verified, and person B said, looks okay. The standard is asking to person B, the 4I principle, prove how did you decide that the logic program by person A functionality is correct. How did you do that? And that's completely, of course, different than just having a second name. And that's it. In the meantime, we have some more questions coming in. Let me see. It's still the same person. So if this is okay, because there are quite some generic questions, nothing to do with the life cycle immediately. It's more detailed. So I will try to see if I can handle that during the question section. All right, so let me continue. What is the life cycle all about? As I just explained you step per step, it's a systematic approach. It will help you to describe the activities in text, in requirements. It will also define by functional safety management what are the responsibilities. In other words, accountability, responsibility. Who is accountable for what and who is responsible to carry out. It needs to identify what competency is needed per phase. When does the project manager, when does the functional safety manager decide what members in his team he will select based on maybe previous experience, based on maybe some know-how, based on some competency. So one of the requirements from the IEC SIG 1511 is to prove that you are competent to the activities which you are responsible for. That's one of the competency schemes that we are doing through the program from TOV Rhineland, which is the Functional Safety Engineer SIS. In other words, we do a formal training of 3 days. Of course, the engineers need to prove to us some experience before they are allowed to set the exam. There's a minimum of 3 years experience needed for that specific program from TOV Rhineland. And then there is a closed book exam. That means we are checking the knowledge based on an exam, and based on the measurement of the knowledge, we will make a decision that based on the test and based on the momentum of his brain power during the exam, he needs to prove a minimum percentage in the exam to pass the exam, yes or no. It deals also with functional safety management. That means the management of functional safety is a addition to shall requirement, where addition 1 was you should, now you shall. And with a shall command or a shall normative requirement in the standard, functional safety management is personally for me a lot more important than any SIL number in your project, because that is where the real functional safety will be a evidence of success, that we need to prove that we did everything possible in quality measurements to reduce human failures in carrying out their activities. We will have some methods, some monitoring methods called verification. We will have validation. We will have assessments, and we will have audits. And all 4 principles that I mentioned here, verification, validation, assessment, audits, they are more or less the same, but they're all different. They are different in when you do them, who will do them, etc. That is the backbone of the life cycle quality to prove that you carry out your activities correct or not. The different life cycle can be defined for end users, for developers of hardware, software. For instance, if GMI is building a new device or is developing a new device, they will follow the life cycle, of course, of the IEC SIG 1508. But if an EPC contractor is doing an engineering on a project, they will not follow the SIG 1508. They will follow the life cycle from the IEC SIG 1511. Or if a cabinet builder is designing a system, and they're not involved in, for instance, the hazard risk assessment, they have nothing to do with phase 1, phase 2, and phase 3. They have been giving the requirements called the safety requirement specification. So the first phase activity for a cabinet builder is typically starting with phase number 4. And phase number 4 is called design and engineering of the SIS. Of course, if the same cabinet builder would go on site and do installation and commissioning, that means the activity gets dragged over into phase number 5. So it all depends in what activities you are active in. That will reflect to what activities of the life cycle you need to prove compliance to. All right, let me see if I can launch this poll, which is the edition number 2. Let me go back. Okay, the edition 2, that's this one. Okay, if everything went well, you should see that. So, edition 2 life cycle activities and requirements are A, changing per SIL level, B, irrelevant of the SIL level, C, not applicable for an SIS built before 2016, D, none of the above. So please. Okay, in the meantime, I'm reading here one question loud, which is related in general terms to the life cycle. Can you point out precisely where in the norm it is recommended to use other means of risk reduction other than a SIF? Well, I will answer this live. You have to go in chapter 9. Chapter 9 is layer of protection analysis. Layer of protection analysis is covered also in part number 3, which is the informative section. But if you want to read exactly more details, which is described, as I said, in chapter 9, which is the LOPA, the reference that we are using in our training courses is coming from the latest book from CCPS, which is the Chemical Center of Process Safety. And the latest book is by memory 2015 from LOPA. in that book are quite some good practical examples. But to answer your question, in the standard or in the norm, IEC 65011, it is in chapter number 9. And I'm sure if you read chapter 9, you will see other means of risk reductions. Okay, so I answered this live. Right, 84%, so we should end the poll and continue. I was reading the questions, so oops, I did not share the results. Let me. Well, I was afraid to see that the majority is wrong. The life cycle activity requirements have nothing to do with the SIL level. It's regardless if you're building a SIL 1, 2, or 3, or 4, have nothing to do with each other. And that's a misconcept. I honestly do not know. I'm only for 25 years active in safety business, and I have no idea how this myth in the industry is confusing engineers, that they all think, oh, but for a SIL 1, there is less to do than for a SIL 2 or for a SIL 3. It's nothing to do with that. The life cycle activities, again, are general or generic activities that you have to carry out to prove compliant to the 65011. And if you have now 100 SIL 1 loops and only one SIL 2 loop, or you have maybe 50 SIL 3 and 200 SIL 2 and 1000 SIL 1s, the activities descriptions remains the same. It's the same description, the same life cycle. So answer A, wrong. What is the correct answer? Irrelevant of the SIL level. That's luckily we have 36%, so nearly 1/3 is on the right track. The other ones, they better start to do some, let's say, fundamental basics in functional safety. That would certainly clarify or help them that this wrong concept or understanding could be solved. Not applicable for SIS built before February 2016. That would be great if this would be true or not. That's not, because that's now covered in a clause in the new edition 2 as a kind of a equivalent grandfather clause. And I had 5%, none of the above, which is of course also not correct. So the correct answer should have been B over here. Okay, let me keep on going. Okay, so if I summarize this for you, there are 3 main blocks that I always refer to in my training classes. Everything starts, of course, with a good hazard identification, a good analysis. And of course, a good analysis, the question is, what is good? Well, the subjectivity on the likelihoods of events, that is where the first discussion comes in. Because it's like asking someone, do you have a glass ball, and can you tell us how frequent this hazard potentially can happen? Of course, if the hazard happened before and there are some historical data that you can refer to, that's sometimes what we will have to do. But then if you have a new, and like today now in the industry, hydrogen is one example, which is a new, let's say, application, or not new, it's one of the latest applications that is more and more and more being used. The question is, when you are designing a hydrogen plant, how do you estimate how frequent a potential hazard can happen? Do you go to other gases? Do you go to other liquids in able to say there is maybe a line break or something? Or where do you come up with your frequencies? That is classically what could be a challenge in your project. So the first block is identify your hazard, analyze, assign your risk, do your LOPA, define if you need extra risk reduction, yes or not, within safety requirement specification. That is block number 1. We call it the analysis phases. Then we physically have to start to build a system that's called the realization of your design and engineering of your SIS. Installation, commissioning, and validation. That's all here my block number 2. And then we have the final block, block number 3. That is, of course, the longest phase in duration in the life cycle. For instance, a project can last maybe 20 months between block 1 to block number 2. But then the end user will use the factory for 20 years able to operate and maintain the system. So certainly in block number 3 is a lot more room for people to make mistakes. That means that also here in the operator and maintenance and the modification and potentially the decommissioning, there is a need for actually also manage your activities. Everything which is shown here in blue, which I call here this number 4, that's the general management for all the activities. That's the general planning for all the activities. And that's the general verification for all the activities. What I just explained is here then being backed up with some text. The analysis phases is phase number 1, 2, and 3 of the life cycle. Requires, of course, that you have done your process hazard analysis that is performed by using some techniques. One of the techniques that I'm sure you have heard of is called HAZOP. Can also be done with bow tie analysis. There are many different techniques. The standard will not dictate to you, use HAZOP, use bow tie, use this or that. They just say you shall identify the hazards, you shall analyze the hazards, and you shall reduce the risk towards your tolerable risk. How you do it is your problem. But the standard will give you some examples with different techniques that you can use, and you are free to choose. Then you're required to allocate safety functions to existing layers, that is your LOPA. And if your tolerable risk cannot be met, that is where we will define how much more risk reduction do I need. And that is where we will define that into a safety requirement specification. When there is some narrative, some logic controller involved, that is where we will also need to define the application program safety requirement specification. And before we continue, what is normative required, that's quite important, is your assessment stage number 1. And assessment stage number 1 is the first start to find out how this project will continue and how potentially they will achieve functional safety, yes or no. We go to the realization phase 4 and 5. In the realization phase 4 and 5, we have here the design and engineering of the system architecture, the hardware configuration, the application program, and system integration. That is what I told you. Typically, system manufacturers, cabinet builders, whatever you call them, will start to design and engineer the system. Then you need to go on site. You need to do the installation commissioning. That means that during the commissioning, you will connect all your instruments together. Before you will start to go live with your safety management system, you have to do a final test, which we call the site acceptance or the validation test. And that is before we introduce the hazards in our production facility. That is where we will have to go here to stage number 3. So after designing the system and after you have done the FAT or the factory acceptance test, that is where you see here stage number 2. Again, it is normative important. Before we ship it on site, we like to carry out, or we should carry out, that stage number 2. Sometimes we split stage number 2 that we do based on the FAT procedure. We do a stage 2 before they start with the FAT, and then we continue with taking the FAT results with us when we do a stage 3 on-site. So stage 3 on-site is always on-site with the end user or with the installation physically installed. And that is what I called before the PSSR. Last but not least, 6, 7, and 8, that is the final activities for the end users. That is where you have to operate. That's where you have to maintain your activities. You need to collect your field data. The new edition 2 is based on quality feedback field data from your own installation, not from someone else, not from a book that you bought, not from a database that you were giving by any institute or whatever. It's about your data in your installation, with your experience, with your proof test, with your environment, etc., etc. So you can see we are looking for data from the installation itself, not the theory from out of a book or a database. We need to see also the proof test efficiency and foremost the consistency between different people. FSA stage 4, that's periodic, already mentioned to you. And FSA stage 5 is twice before and after the modification. General phases were phase number 9, that's FSM. Phase number 9 is the verification. Phase number 10 is the structure and is the FSM. Let's do this one more time, because I was looking at this screen here and reading these numbers. And to be logically, I should put 10 first here, then 11, and then 9. Because 10 is my FSM, that's the one over here. 11 is my structure and planning, and phase number 9, which is on the right-hand side here, is your verification. All right, so we have the last poll for you, or the second last poll. We have one more poll at the end as a feedback. Now, let's see if I can do that. Get back into the competency review. I'm again interested to know who of you has followed a competency program in the market, which there are many of them available for you. The one that I am personally mainly active in still is the functional safety program or the competency review program from TOV Rhineland. We have, in the meantime, I'm proud to say, we are the leading program in the industry. It's quite simple to know why this is, because we are existing 20 years this year. We started in 2004. Myself, I nearly trained personally 3,000 engineers worldwide in 200 plus different trainings worldwide again. But we have, in the meantime, in the program, we have nearly 23,000 engineers being trained worldwide with that specific program. So who of you have followed competency review program on the 6, 15, 11 edition 1 and still has a valid certificate? Because certification is typically valid for 5 years. So I would say wonder that someone would still use the certificate which was acquired on edition 1, because edition 1 has been obsolete in 2016, which is 8 years ago. That means your certificate is expired. B, edition 1, but your certificate is currently expired. That's the other solution that you click. C, edition 2, and you have a valid certificate. That's also coming in. And again, we need a few more clicks for those who are still on the program. None of the above. Well, afraid to say that what I was afraid of is actually being proven to be correct again. The majority of the engineers in this webinar are coming quickly in here to listen to FuncSafe, which is a good thing to do. But you never follow the training program yet. That's mainly also why we probably have all these questions coming into the Q&A. So none of the above. Let me quickly share that. Because my screen was enter poll now, and now I will share the results. So as you can see, 14% was trained on edition 1 and has a valid certificate. Personally, I would doubt this is correct. Or maybe there is one institute in the industry, without naming them, because we don't do on any competition, we stay neutral, but there is one institute worldwide that is saying, if you are trained by us, it's valid for life. Well, I'm smiling because that's absolutely rubbish, if you ask my personal opinion, because edition 2 made edition 1 obsolete. So how can you say you are competent in an edition which is no longer accepted in the market? Wish you good luck if you believe your certificate is still valid. We have edition 1 and your certificate is expired. I think that is correct, but my advice would be follow a new edition 2 training and prove again you are competent. 32%, that's not much. That's only 1/3 of the people listening in have a valid certificate on edition 2. And we have more than 50% which are or never followed a competency program. This is not so shocking. In other words, you don't need to follow a program. You can say, my name is Paul and I know everything. Then if I'm the inspector, I have to prove that you, Mr. Paul, are maybe competent or not competent. So how do you prove that? And able to do that, of course, in the industry, we know that the engineers are often challenged by whatever measurements they will have. You need to prove that you are competent and for what you are accountable. Summary. Please stop using only SIL number and PFD and believe you are safe. There's nothing to do with the backbone of the life cycle. The life cycle has nothing to do with SIL levels, as I also had one of the poll questions. Function safety life cycle is nothing more than a systematic approach on how to achieve your safety in the process industry. It will not be done automatically. As I said, They give you recipes, but you still have to carry it out. You still have to prove it. You still have to use competent people enabled to carry it out and enabled to prove that you are compliant to the standard. Right, we can help you as GMI with the following services. This is the Lifecycle service for the SIG 1511. And since 2016-17 requirement for cybersecurity or for security risk assessment, which is not only cyber, it's also the OT security risk assessment. That is what we can help you with, referring to another standard which is called the 62443. As I mentioned, one of my main activities still today is doing the Functional Safety Engineer SIS Competency Review Program from our friends from TOV Rhineland. In the same program from Rhineland, we're also holding the license to give you the fundamentals of cybersecurity and also to give you the IACS, stands for Industrial Automation Control System Cybersecurity Risk Assessment. All of those trainings will lead into an exam with potentially, if you pass the exam, a personal certificate on your name, valid for 5 years, because there's an expiration date for 5 years. The main reason is that there is a periodic assessment required from a standard. That's also what we are doing. And if there is a new edition coming out, like the edition 3 from the IEC 61508, may be out in 2026, if I remember the correct date, 2026. So in 1.5 years, we may have a new edition 3 coming out. That means we need to prove again we are competent in the latest, newest edition. All right, that's the book. If you don't have the book, you can go on the GMI website and you can require a book. In that in that book edition 4, the 4th edition, I wrote chapter 7 and 8. Chapter 7 is the SIG 1511 summary, as we just have been explaining the life cycle. That's also captured in there. And in chapter 8 is a safety requirement specification. All right, let me stop sharing this and I will quickly go because I see that I'm running a little bit out of time as usual. Right, sometimes difficult for us to keep it short as there is so much to explain in a short time. The questions and answers on the webinar that we received. Do the requirement for the IEC 61511 lifecycle vary depending on the type of plant? In other words, when I'm reading this question, I think the engineer was trying to ask, would the lifecycle be adapted to the specific type of plant? For instance, we have a refinery, we have a chemical plant, we have a hydrogen plant, or whatever type of plant we have. Well, my answer is very clear. I hope it's very clear. I was doing my best to try to type it clear. Well, the life cycle, as it has been defined in the SIG 1511, provides you a framework, as we just explained you, on how to define, how to engineer, how to operate, and how to maintain. But that is applicable throughout the process industry. And the process industry, which are targeted by the SIG 1511 life cycle, edition 1 was oil and gas, chemicals, and petrochemicals. Edition 2 added 2 new applications. One is pharmaceutical and the other one is food and beverage. So the short answer is no. The life cycle remains the same. Whatever type of plant, if it is oil and gas or pharmaceutical or food and beverage, it's all the same life cycle. We will not change how we will adapt the life cycle towards the type of plant that you would be working in. So this life cycle serves as general guidance for the activities related to your SIS application across all types of the process industry. Important difference between the SIG 1511 and the SIG 1508. Well, here I thought I'd just put a picture. I will not explain the right hand as I have done that before. Look at the left column over here, or the left picture. That is the IEC SIG 1508. You see a similarity. They have also general blocks, very similar to the SIG 1511. And in the middle, we have the same phases as we have with the SIG 1511, but here we are talking specific for the design of hardware and or software devices that the manufacturer will have to follow. So it's also a systematic approach. It's also go with requirement specification. It also go to physically design and development of the system. It will also look into how to install and actually commissioning that system. It will also give you guidance on how to operate it. There will be planning for operator and maintenance. There will also be a definition on how to test it, etc. So all this is the life cycle of the 61508. And clearly, the 61508 life cycle is not meant to be used for the process industry, because the process industry, that is the 61511. That is specific here for a development of an EEPES. Right, that's a long question, which my camera is blocking the question. What are the more frequent issues you have found when working with your clients with regards to adhering, understanding, and actually implementing following a compliant function safety lifecycle within their existing facilities and within new projects? Oops. Well, I'm trying to be polite and I'm trying to be neutral at the same time, which is not always easy for me. But I will answer it as followed. In our professional experience, it's quite uncommon for an end user operating company or for an EPC engineering company to fully embrace the true principles of functional safety. Yes, they all say we are following the life cycle. Yes, they all say we do have requirements. Yes, they all have a bunch of procedures, etc. But the question is, how many of those engineers that are listening into this webinar here today are following the instructions as described in one, their quality management system, and two, the functional safety management system? A classical excuse is, I'm an engineer, Tino, I have no time to read the entire quality procedure, the entire functional safety management procedure. I'm under pressure of time and planning. I have to carry out my activities. Well, if you have an engineering practice described in a quality procedure, which is called functional safety management, but you cannot prove evidence you have been using it, it's going to be quite difficult. Most of the engineers or most of the companies we deal with, they blindly look at SIL numbers and they blindly look at PFDs. And you know what PFD is? PFD is an estimate. And I give you a very simple example that hopefully any engineer will very simple understand. Can any one of you, by estimation calculation, define when you will die? And that's a simple question. And the answer is none of you. Not me, not you. No one can define that. We can all estimate. You know, I have a very serious back problem now. It started a couple of months ago. If someone would ask me last year, would you have 2 months ago, or would you have that date predicted that you would not be functioning anymore the way you have to function? That's the same as you do on your instruments. When you have a PFD, when you have a SIL, you estimate when that device will not work when you need it. The problem is, the moment an engineer sees the number on paper, they start to believe it, or they start to dream it. Well, stop dreaming, stop blindly focusing on PFD. It's nothing more than an estimate. Try to enhance the quality of your activities by following the life cycle, by applying functional safety management. That's the third bullet. The foundational reason behind functional safety life cycle is to focus on the quality approach on your activities by using management, by using assessment. Unfortunately, despite 20 years having the 61511 in the market, the real essence of functional safety management and assessment is still today, 2024, 20 years later, mainly overlooked, mainly forgotten, mainly bypassed for whatever excuse the project engineers will tell us. IEC 61511 is part of the fundamental of a post-grad discipline related to SIS, especially the quality of the SRS safety requirement specification. Right. Well, the 61511 life cycle is a critical component for any postgraduate curriculum focusing on the safety implemented system. In other words, the life cycle or the 61511 is written for any level of know-how of engineer. but you need to prove a certain basic fundamental understanding of, let's say, functional safety before you will understand what the life cycle, of course, is trying to achieve. But I also agree to what the question was asking. The key element or the key document for sure is always your safety requirement specification. And the question is, how good is your safety requirement, or what is the quality of your safety requirement specification that you are using today? Will your one safety loop have 29 items being described? Because the standard is saying you shall describe and you shall include, but they make the sentence closing paragraph, they say as applicable. So a creative engineer is saying, oh, that's not applicable for me. And I'm still complying because the standard allows me to say you shall describe, you shall include as applicable, but I think it's not applicable. And your subjectivity of not applicable is allowed by the standard. The question is, will every engineer think about the same definition, the same way, and will they all have the same subjectivity? And that is the real essence of having a good quality safety requirement specification. That will be essential as a document the requirements necessary to achieve your safety integrity level with your safety system. The key aspects of SRS quality are the clarity of the description, the completeness of your description of your safety requirement specification, the traceability to documents. Why was it decided to do it this way? What is the reason for that? The consistency, that means that all your type of architecture, your loops needs to be consistent to whatever is described in your requirements. How have you verified that? How have you validated that? And of course, also in the future, you need to look in the change of management. We have some more live webinars scheduled online. And before we will launch the last poll, let me quickly look as the questions are starting to grow. There is more question in than I can potentially handle. What exam can I take to be SIL certified? We never certify you as SIL. We certify you as a competent person. So SIL certified, clearly that is a wrong interpretation. Maybe my explanation or my English was not as clear as I was hoping to be. So we can train you to be competent in the fundamental basics of, let's say, functional safety on the 6.15.11, but you need to have already a minimum of 3 years experience before you are allowed to set the exam. So that is answered live. Let me see, is there any online quiz or exercise to practice before I attempt for SIF certification so that I can practice the same? Thanks. There are some online exams, not from TU Viranen, but from another institute that was so clever to put an old exam online. So people are using that. We have a data pool of exams that we are not allowed to share, of course, on internet, because you can imagine if all our questions are on internet, there is no exam, it's a giveaway. So, but there are some items we do have in our training course. We do have some sample questions that we are using. So that is what we are giving as part of our service when we are doing the training itself. So I will also close that one. I already requested the GMI book, but not yet received. I would recommend to those or that person here to send an email to either Gabriele or to me. That will also be in the slides, and then we can further follow up. So that's also answered live. Where can I buy your book? That is another person asking the question. Again, if you will see the email on our slides, you can send us an email and then we can explain you how to get a book. The book is typically free of charge, and it's typically either by the representative in your area where you are living or working, that you can get a book sent to you, or you can ask to GMI. Also answered live, so that's done, that's done, that's done. Okay, so that's also answered live. And then there are 3 more questions, very briefly. Please, for the safety integrity level, how is the level of instrumentation system assigned? Is it through a workshop or through HAZOPs? Then what is the SIL weight? Well, that is like asking what is the relation between the sun and the moon. Can you please give you 5 seconds to explain? So I need at least a few days to give you some basic fundamental understanding. So excuse me so blunt to say, I cannot answer this here live. because there is too much in the question that I can see that your understanding is certainly not to where it should be in terms of understanding the 6, 15, 11. So answer life done. Then in a type of centrifugal Siemens compressor system, what standard is based on and how is still a requirement on the system conducted? What layer of protection is required here? Again, listen, we do webinars, we don't do free engineering for you. So excuse me saying, I will be blunt, answer live. No, I will not answer that. One more, how is SIL numbers classified? For example, HIPS is classified as SIL 4 and pressure down transmitters are classified as SIL 1 or SIL 2, as case may be. What evidence? Well, that's all coming from the same person. There is a lot of basic missing understanding in here. I will answer this because I can just see how wrong people can start to believe that they understand safety. SIL 1 and SIL 2 transmitters cannot be used for SIL 4, period, point. There is no more discussion needed for that. So a SIL 4 requirement for a HIPS is also a misconcept from the industry. I tell you something, IEC 61511 does not, and I repeat, does not allow SIL 4. IEC 61511 is maximum SIL 3. If, however, you would ever go in SIL 4, the standard clearly say use other means of risk reduction to reduce the risk because SIL 4 is not accepted by 61511. The question or the confusion comes, there are some manufacturers or there is another myth in the industry saying a HIPS, for people who do not know what a HIPS is, that's a high integrity pressure protection system, needs to be SIL 4. That is totally rubbish. A SIL 4 is not allowed in the process industry. Where is this coming from? They use a solid state controller. Solid state means not programmed by software, but by solid state, means wires and with hardware electronics. That box is being certified by IEC 61508 for SIL 4. And therefore people say, if you use it on your HIPS, you're going to have a SIL 4. Well, certainly not true. SIL 1 and SIL 2 transmitters, well, certainly you can never, and I repeat, you can never achieve a SIL 4 with a SIL 1 and a SIL 2 transmitter, not even if you put them in a certain configuration. The thing you're missing here is called systematic capability. Right, I'm done. I'm greatly over time. Apologize for all those, but I see that the most of them are still listening, so that is good. Let me last poll share the one and then I will stop with the webinar. Oh, okay, it's over here now. Let me move this one. All right, so last click for you. How did we do? Well, I will not ask the question myself because it would be a bit selfish to ask. I'm still waiting until saying not in line with my expectation. Typically, it is always somehow in line because the title is always explaining how we will explain or what we will explain our topics for functional safety. Oh, we have a good response. Well, thank you for all the people showing all the efforts to remain 15 minutes extra online because webinars are supposed to last for an hour, but there were so many questions coming in and I wanted to help this engineer asking me all the questions to answer as much as possible. All right, so let me end the poll and let me share that and I will give the word over to my colleague Gabriele to do the final word. And I would say thank you from my side.
Thank you, Tino. Thank you, everybody. Maybe there are our contacts in the next email, in the next slide. Sorry. So, if anyone were looking for, yes, there are. So, if you need any information, any additional information, or how to receive the book, yeah, just write us.
All right. Well, thank you, everyone. Keep it safe and try to remember it's not about SIL levels. That is certainly not the reason why we have functional safety. It's more about the quality of activities. That is my last sentence that I will do today. Thank you and take care.
Have a nice day. Bye.
Thank you. Bye-bye.
Bye.